Woodruff from Optimized Financial Systems, and I will be taking you through a demonstration of our ATM and branch cash management application. The ATM and branch management cash solution serves as an add-on service for ATM owners. With ATM, the owners usually pay a set price to reload every ATM, regardless of how close all the ATMs are to each other. Owners also pay for emergency deliveries, and when an armored car service makes a delivery, the remaining money in the ATM is removed. This money sits idle for a few days while it is counted and processed before it goes back into circulation. For an ATM owner, costs fall into 4 categories. There are costs for deliveries, interest and insurance costs for holding cash. When cash is moved, there is a cost of dead money while it is processed. And finally, when an ATM runs out of cash, the ATM owner is losing money in fees that could be the charging customers and or losing customer goodwill for lack of service. Holding more money will reduce lost fees and delivery costs. Holding less money will reduce interest and insurance costs. Delivering less often will reduce delivery and dead money costs. With all these costs competing with each other, finding the right balance to lower the total cost is a challenge for ATM owners. This is where Optimized Financial Systems' analytics-based approach helps. We apply predictive and prescriptive analytics to the ATM cash management problem in order to reduce the total cost of ATM ownership. In this demo, I will show you how we use a distributional demand forecast, apply prescriptive analytics, generate policies, and save the ATM owner between 6 and 40% on their ATM cash management costs. The first step is to set the parameters for each ATM. These include the costs we just mentioned: lost fees, interest and insurance, deliveries, processing time, and a few others, such as the size of the packets, known as bricks, that can go into the ATM. This also is a large ATM that holds 5,100 $20 bills, so its total capacity is 102,000. The image shows a sample distribution for the forecast. Almost all forecasts are wrong, which is why we care about the distribution of the forecast too. This example shows a forecast that is skewed to the left. The forecast can take any shape and accurately describes a demand distribution. Each day is likely to have a different forecast. Fridays are busier than Mondays, and holidays are busier than regular periods. We usually forecast out 30 days. As you can see from the chart of the daily demand, some days have little demand while others have more. And in some days, the dispersion in the demand is greater and could potentially use up the entire stock in the ATM, while other days the dispersion is smaller. Days like day 26 will have very high demand, but could have demand at half the level, while days 7, 8, and 9 have very low demand. These 2 days are very important, and we'll revisit them later. Next, I'm showing you how many smart operators are already creating policies today. These are policies based on static forecasts. They call for the ATM to be restocked when the on-hand quantity of cash is less than a percentage of the following day's demand, and set a target of number of days that the cash should last. In this example, the reorder point is 1.2, meaning at 120% of forecast, we should reorder, and we should order whatever is forecast for the next 3 days. In the chart you see all the blue dots represent the point at which we need to reorder, and the blue bars represent how much we should actually order. This is the optimal policy. It is very similar to the forecast-based policy. There are some differences. For instance, on the 7th day, the reorder points and the reorder quantities are higher. This is because the demand for the next 3 days is low, as I pointed out before, but the day after that it goes up. So the algorithm adds an extra day of inventory. On the other hand, on the 24th day, over here, the order quantity is much lower. This is because the demand for the 24th and 25th are low or medium, while the 26th day is higher. And the algorithm knows that it's going to have to order cash that day anyway, so it economizes the 2 days before, knowing that it will need to be full the 26th. As we can see in the demand, days 7, 8, and 9 are low, and day 10 is actually fairly low, so that's why it tries to make a higher demand order policy there. Whereas days 24 and 25 are still low, but day 26 is probably our top day, and so there's no point in trying to meet the demand for that top day by ordering on the 24th. In our last section, we've added a couple more policies. One is a straightforward policy, which is to fill up the ATM every time it is empty. And the second is a policy I've created by trial and error. I've looked at the optimal costs and key performance indicators and have adjusted the reorder trigger and order quantity so as to most closely match the optimal dead money and inventory levels. With the benefit of hindsight, I created a policy that almost matched the optimal policy in terms of average cash levels, average dead money, and average shortage. I simulated the policies over a 30-day period 100,000 times. The results are in the final chart. If we look at the results for filling an ATM every time it is empty, we see that the costs for shipment and holding are actually lower than what the optimal one is. But if you look at the lost fees, they're several orders of magnitude greater. So while we are economizing on some of the costs, we're more than making up for it in the other areas. And so the optimal costs here are 54% lower. The first forecast policy has less average cash, as you can see over here, a little more dead money, but you can see the total optimal costs are about 9% lower for the optimized case. Finally, my highly contrived policy that orders 101% of demand and ordered 3.4 days of cash on hand has a slightly higher cash shortage, and most of the other costs look the same. The costs of these policy, even after trying to match the optimal policy and having the benefit of hindsight, are still about 3% higher than the optimal policy. What this means for ATM owners is that even if they're using a good forecast and a well thought out restocking policy, we can still save them between $59 and $185 per month per ATM. I've just given you a demonstration of how Optimized Financial Systems is able to use any forecast distribution, the specific operating parameters and costs of an ATM, and generate a set of optimal policies that reduce the total costs of maintaining the cash levels in an ATM. These policies, which feed into an existing reordering system, can help save between $59 and $185 per ATM per month. Thank you for your time, and we look forward to hearing all your questions.